All right, here we go. Uh, I accidentally, in the other class, started teaching out of 11.3 instead of 11.2. My plan was to do 11.2 today, but I started teaching 11.3, so I just kept on going with it, and I'll hit 11.2 tomorrow. All right, so that's why we're jumping around, just because I just want to do the same lesson we did in the other class. Okay. So anyway, we're going to do section 11.3. It's about circles. And this whole chapter is about area, so guess what? We're going to do the area of a circle. Right, of a circle. Yeah, exactly. You learned that when you're a little kid. You probably learned that 4th, 5th, 6th grade, something like that. Somewhere in that area, somewhere in those grade ranges, you probably learned area of a circle. And for some reason, that's one that just sticks with people. Okay, pi r squared. It kind of rolls off the tongue a little bit. So the area of a circle is pi r squared. If you're really concerned about how they get that, they go through just a little bit of explanation where they got pi r squared. I don't think you guys really care, and I'm just not going to go through how we get it, okay? But it's in the book if you want to look at it. But just remember it. It's something, again, it's another formula that has to be memorized. When we do area, there's a lot of different formulas for a lot of different shapes, and you just have to keep them straight. This is one more that you got to keep straight, pi r squared. So let's put a circle up here, just see how to work this. Now we actually skipped the chapter. We skipped chapter 8. Was it 8? No, it was 10. We skipped chapter 10, and 10 was all about circles. So there's a lot of things about circles, but there's a few things that we didn't talk about because we didn't do the chapter. But I think you know already. That little dot right there is called the center of the circle. And if I drew a little line from the center of the circle to anywhere on the circle itself, okay, that is the radius, and we just use r for radius. All right, that's the radius from the center of the circle out to the circle itself. Is there only one radius in that whole circle? No, there's a whole bunch of them. Okay, that's right. They all going to equal the same thing. That right there could be a radius, couldn't it? Why? Because it starts where? From the center of the circle, and it goes to a point on the circle itself. Okay, the actual line that makes that circle is called on the circle. A lot of people think this thing of like as a disc or a plate or something like that, or as a frisbee. Okay, that's not on the circle. This is inside the circle. This would be what? Out here. Outside the circle, and if I'm right on the dot, where would that be? It'd be on the circle. You got it? Okay, so that's on the circle. So you could have several different radius. Just for radius would be 1. It would be singular. I'll put singular. And radii, it's kind of a crazy looking word. You don't see two I's next to each other very often in English, but radii would be what? Would be plural. So if I have two, I don't say radiuses, I say 2 radii what? Radii. Okay, so 2 radii, 3 radii, 1 what? Radius. Okay, so here we go. What if I extended this?
It'd be a diameter.
Right, see, you learned a lot of stuff in your earlier days about circles, and that's exactly right. Now the diameter has got to go through the center of the circle. Let me drop it down just a little bit, okay? The diameter has to go through the center of the circle. I can't draw a line like this and say that's a diameter. Just because it hits 2 ends of the circle doesn't mean it's a diameter. What does the diameter have to do? It's got to go through, not the middle. We don't say middle. What do we say? The center. Okay, so if I did it like that, now that would be a diameter, wouldn't it? And of course, both diameters are exactly the same length. And there's also another relationship between the, that's right. Okay, this is the diameter, and the diameter is what? It's twice the radius. So if I take this radius, let's just make up a number. Let's say it's 3. So the radius is 3. What would the diameter be if the radius is 3? The diameter would be 6. Okay, what if I told you the diameter was 10? What would the radius be? It would be 5. Now listen to what I said. If the diameter was 10, that's the longer one, what would the radius be? It would be half of the diameter, which would be 5. Okay? So we got to keep some of those things straight before we even talk about the area of the circle. All right, so let's get rid of a couple of things here. Let's get rid of this, get rid of this. Let's put a radius in there again. It doesn't always have to go like perfectly to the right like this. It could go anywhere in there. So we'll say that's the radius. And let's just say the radius is 5. And I want to find the area of this circle. So you got to know the formula first of all. The area is pi r squared. So watch what we do. We put pi. Now you know what pi is. It's 3.14, but let's use the calculator button for pi. I think that's what they do in the book. So on this calculator, do you see the pi right there? Little pi symbol? So on this calculator, you hit second function, and then you hit this button. There's the pi right there. If I hit equals, it shows me what pi is. On your TI-30, I think you actually have a button all by itself that just has a pi on it. Am I right on that? Where is it? It's like on the left-hand side? Yeah, it's like about 3 down on the left-hand side if you're using a TI-30 XA. Right? You just hit it once and it pops up, right? I got to hit the pi, so I got to hit second function, this number, then equals to get that pi to show up. On yours, you just hit the pi button, boom, pops up. All right? Everybody with me on that? How to use your calculator? So use the pi button when you're doing these problems. So let's go back to this. So what do we do here? Pi times the radius squared. What's the radius of this circle? It's 5. And we square the radius. Don't square the pi. For some reason, a lot of people go 5 pi and they square both of those things. No, you don't square the pi. The only thing you're squaring is what? The radius. You're only squaring the radius, which in this case happens to be 5. All right? So I could do this in my head. 5 squared is what? 25 times pi. Now let's do this on the calculator. Make sure you know how to do this on your calculator. If you have a calculator like this one, let me show you. It's actually kind of nice. All you got to do is hit 25, and you don't even have to hit times. All you got to do is hit 25 pi. And then you hit enter, and then there's your answer right there, 78.5. On your calculator, if you have a TI-30, you would hit 25. You wouldn't just hit 25 then the pi button. You would hit 25 what? Times the pi button. You got to hit equals though, right? And then you should get the same exact number. No difference at all for the answer. Do you agree? Are you doing it? Well, it's 0.5 because that 3 doesn't round the 5. All right, so we'll say it's 78.5. So that's what the area would be, 78.5. And let's say it's in centimeters, so it's centimeters squared. I'm not really all that concerned if you put the squared or not. We're not going to do perimeter with these. That was in the chapter 10. Maybe another day I'll show you perimeter, not today. I got one more thing to show you, though, about the circle. Everybody okay on that? So that's the area of the whole entire circle. So if I wanted to find, this is shading in, okay? If I want to find the area of that whole entire circle, then it's just pi r squared. That's how many squares you could fit inside this circle. Make sense? Okay. Let's do another circle. And we're going to mix this up just a little bit. Watch, it's a little bit more complicated. Not much, just a little bit. So don't look at it and say, oh no, I'm not going to be able to do it because he said it's more complicated. Look at this. Let's say this angle right here is, I don't know, 37 degrees. Do you see this angle right here? It's formed by these two radii, correct? Let's say the radius is, I don't know, 8. I'm just making up a number, okay? What I want to do here, I don't want to find the area of the whole entire circle. I just want to find the area of this chunk of the circle. It's like you took a piece of pizza out of the pie. You follow me? It's a piece of the pie. I just want to find this shaded area right here. I'm not finding the whole entire circle. But what if I was finding the whole entire circle? What equation would I use? Pi r squared. In this case, what is the r? 8. So that would be the whole entire circle. But that would be too much though, wouldn't it? Because that's more than what I have shaded in. Well, what do I have shaded in? I have 37 degrees shaded in. But 37 degrees out of what? How many degrees in my whole entire circle? 360 degrees. You knew that, didn't you? Okay, 360 degrees in an entire circle. So look, I'm not doing the whole circle because the whole circle would have gone all the way to here, wouldn't it? I'm only doing this part of the circle. So I want to find out what fraction, what decimal, what percentage of the circle am I trying to find? Well, I'm trying to find out 37 what? Out of 360, that's right. Because there's 360 altogether, right? So I'm only finding 37 degrees out of the whole entire possible 360 degrees. That's the only thing different right there than finding the area of the whole entire circle. Does that make sense? Because watch this. I didn't do this in the other class, but this might make a little more sense. What if I did this? What if I went this whole thing right there. How many degrees is that?
180.
It's 180. So what's 180 out of 360?
Two.
That cancels out. It's a half, isn't it? So look, it's half of the circle, isn't it? So 180 over 360 is half of a circle. What if I went up to 90?
That's 3/4.
That's right, because 90 degrees is what? It's 1/4. So 90 out of 360, that cancels. That's 1 over 4. That's a fourth of a circle. Now 37 doesn't come out to a nice pretty fraction like that, but it's still, you get it the same exact way, don't you? All right, so you're not finding half the circle. You're not finding a fourth of the circle. You're finding 37 degrees out of the whole entire 360. Okay, and that's what the shaded in part. So plug that into your calculator. That's what the shaded in part is going to be. That's the area of the shaded in part. Does that make sense? Let's plug that in and just see what we get. So let's hit 37. I'm going to put this in parentheses actually. I'm going to hit 37 divided by 360. Okay, times, actually I can just put pi on this calculator, but then I'm going to hit times 8 squared. I can do 8 squared in my head. What's that? 64. It just saves me a step on my calculator. Hit equals, and there it is. 20.1 decimal place. What would it be?
7.
7. So the area of this would be about 20.7. It's approximately. It's not exactly, because pi is an approximate number anyway, and that's another story I'm not going to get into today. All right, that's how you find the area of that particular sector. That's not so hard, is it? So as long as you know that angle and you know the radius, you can find the area. Oh, I didn't use that word. I used it, but I didn't write it down. Look, if you do a chunk of that circle, it's called the sector. S-E-C-T-O-R. It's called a sector of the circle. That just means a part, a chunk. A piece of pizza is a sector, all right? So you go to the pizza place and say, I would like 2 sectors, please, of that. They would probably laugh at you and say you're a nerd, but that's okay. Say Mr. Hamrick told me he's a nerd, so they'll understand. I've never said that, and I never will say that. So, all right. So anyway, there you go. That's how you do that. I'm going to give you a worksheet, front and back again. Do the worksheet. That's due tomorrow.